Obscure facts of octopus adaptations, from clever weapons to incredible deformations. Octopuses are distinguished from their counterparts by having arms instead of tentacles. These creatures display 8 unique appendages, as their name suggests. However, it is necessary to avoid misinterpreting these limbs as tentacles, as octopuses unequivocally have arms. While these terms may seem synonymous to the average biologist, there is a great deal of difference. In creatures such as squid, the tentacles tend to be elongated, and the suckers move exclusively on their tips, serving mostly as hunting tools. In contrast, the arms of cephalopods have suckers distributed along their entire length, equipped to detect smells, tastes, and sensations. This distinction becomes clear when comparing the squid, which has 8 separate tentacles and arms. Human oxygenation depends on iron-rich hemoglobin, which gives blood its reddish color. Conversely, octopus blood uses hemocyanin, using a copper atom instead of iron to facilitate the transport of oxygen within cells. This unique trait not only dyes the blood of an octopus blue, but also the blood of various marine creatures. Octopus arms deviate significantly from paired human appendages, which are an entity of their own. These arms are composed exclusively of soft tissue, giving the octopus remarkable flexibility due to its lack of bones. The most obvious discrepancy lies in the fact that each of the 8 arms houses more than half of all octopus neurons, which are traditionally concentrated within the central brain. This exciting discovery has led some scientists to theorize that octopuses may have a central brain and miniature counterparts inside each arm. Recent studies suggest connections between these brains that go beyond previous assumptions, pointing to the evolving dexterity of octopus arms. Despite the unconventional use of the term intelligence, it has become clear that octopus arms possess an impressive level of cognitive ability. Perception aside, the unusual features of these arms parallel the enigmatic nature of the creatures themselves. Upon reflection, the ability of octopuses to maneuver through openings measuring 1 inch in diameter becomes apparent. These highly skilled acrobats navigate tight spaces incredibly smoothly, gripping openings as narrow as inches. Octopuses are made mostly of flexible tissue that can stretch, contract and warp, and they only have one solid component, their beak. Named for its resemblance to the beaks of parrots, this structure is made of chitin. It is a fibrous substance similar to the exoskeletons of arthropods, and is instrumental in consuming crunchy prey such as crabs and shellfish. Since the beak cannot be manipulated as flexibly as the rest of the body, it determines the minimum size of openings that can be accessed. A stunning demonstration of this extraordinary ability was captured by National Geographic magazine in 2010, which recorded a 600-pound octopus squeezing through a glass hole no more than a quarter of its size.